cord. Ooh, I did it. Has a building with some windows and a door. Okay. He's standing 200 feet away from it. 200. Okay, so with that being said, he says also his angle of elevation, remember the angle of the elevation is looking up, right? Angle straight out to up. Everybody understand that? Okay, notice there was a smokestack, or we could say an antenna, or whatever we want. That's my antenna, like a cell phone. Pretty cool. Actually, smokestack isn't a problem, but I like an antenna because they don't have as many smokestacks anymore as they used to did back when I was a little midget. People are too cautious about pollution. We just threw everything outside. Oh, okay, here we go. So his angle of elevation to the bottom of the antenna slash smokestack is how much? You guys see how we're at the bottom, which is at the top of the building? So basically it's the top of the building, right? So then, the same guy then looks to the top of the antenna slash smokestack. And what's his angle of elevation now? 80 degrees. Everybody see that? Our goal is to find out the height of the smokestack slash antenna, I believe, isn't it? How was that? So, do we know the height of the building? No, we don't. We're going to call him out. Do we know the height of the antenna? That's what we're actually looking for. Let's start and look for this. Okay, so that's what we're looking for there, okay? Now with that being said, I have how many triangles? I have two of them. I have the side with the building, which is X, over 200 feet, and notice that's 35 degrees, correct? Do we have a question there? Robert, which trig function am I going to use? Okay, what is sine? Opposite over, do I have my hypotenuse? No. There you go. So it's the tangent because I have opposite over adjacent, correct? Everybody there with me? Then your teachers use these. Not really. Huh? Puffy, yeah. Miss Jex has like a pink necklace. Okay, so with that being said, that's 35 degrees, and as Robert just said, that's the tangent of 35 degrees equals x over 200. Is that a correct statement? Okay, with that being said, how do I find out what x is? Times the 20 over. What mode should your calculator be in? Oh, 200. I apologize. 200. Okay, go ahead and plug that in. Let's see if we all get the same rough idea. What mode do you think we should be in? Degrees to check. Anyone? 140 point something, right? So am I going to replace x with 140 point something for the next triangle? Yes or no? No. Why? Well, we still need it because notice, watch when I go ahead and draw my next triangle. My next triangle, notice this is the height of the antenna plus the building, so the building was here plus this, so this whole distance is what? Okay, but I'm not going to go to 140 yet. Can anybody tell me why? This is still x plus h, and I didn't put anything in for the x yet. Can anybody tell me why? What did you actually have to do? You round it. Never round until the last step. Okay, if you think about this is my big thing. Okay, if you think about it, if you were going flying to the moon, right? Would you want somebody to round this far off, you know, and it's times by 5,000 miles or something like that? You get what I'm trying to say? That's a long ways away. That could make it move 2 miles away than where your target was. Right? Don't round until the end. So we keep everything exact until the end. Does that make sense? So, let me show you how we can still use this. This is 53 degrees. This is what? 200 again. Does that make sense to everyone? Is everybody with me? Okay. Oops, lost my triangle. There we go. So, if I'm standing here, which trig function am I going to use again? Alex? Tangent again, because I have opposite and adjacent, correct? Does that make sense to everyone? So therefore, I'm like, tangent. This is kind of awkward. I can't really go through my head. There we go. And now what? Times by the 200. What does that even mean? Did I want to solve for x or for h? We already know what x is, right? Technically, we do it. The 140 estimated, right? Okay, so I'm going to subtract that h over. So no x, excuse me. So that's 200 minus the tangent. Oh, not tangent. What the heck was that? Okay. Whoop. Times. See, it still works. Minus x equals h. Or 200 tangent of 53 minus, is it 200 again? Tangent of 35. Is that what x is? 200 tangent of 35. I just use substitution, right? Equals h. Now plug it in. Because we don't want to estimate till the end, correct, Kenneth? 125.36, do I got a second on that? Okay, I got one. Everybody try it if you want to, just so you get your little fingers manipulating into it. Have I told you guys about this ACT thing we're doing? There's this company, eknowledge.com, that the UHSAA, so pretty much the Utah High School Athletic Association. It's $250 worth of information for $20 for the ACT. Gives you videos and things. If you're interested, come and check it out. Go straight down with that. I can make a copy. Okay, negra. Anybody else want one? Okay. Maybe you can get 10 of these. Thank you, Vanessa. So, did everybody get 125 point blah blah blah? 125.36 we were roughly going to 367, so we'll go 37 equals h. Remember, what mode do you need to be in on this one? Degrees. How many of you guys missed points because of the last time because of your mode? Maybe looked at it right. So be aware of that. Check back and forth where you need to be on if you're going to use your calculator, okay? Everybody all right with that? That wasn't too bad, was it? Could you think you could have found that by yourself, knowing the two triangles, or do you really think that one might be a little bit harder for you? It's not too bad. You just had to use the two triangles, find the one, and then come back and get the other stuff, right? Okay, so the next part we're going to go to, we're going to skip example 3. If you kind of want to look at that one, I bet you can do that all by your lonesome as well, but that's not too bad. Oh, excuse me, example 4. Apologize. So we're going to jump to example 5, which I really like the boat and the navigation problem. I don't know why, but I do. Hint, hint. Okay, so with that being said, we need to know how they talk about it. So notice, if they say north, 30 degrees west, what does that mean? They're going in a north fashion, cutting back how far? 30 degrees in the westerly fashion. Remember, never eat shredded wheat, or never eat soggy waffles, or never ever smoke weed. Okay? No, not on that one. papers, I please don't do that. Not that I know. I don't even know what the smell of it looks like. Everybody's like, you don't know that either? I'm like, no. I'm not just... That's okay. We don't need to talk about it and how you know either. Okay? That's a conversation you have between you and your religious leader. Oh, shush your mouth. The smell looks like. Ha! I did. Can anybody tell me another way I could write this instead of north 30 degrees west? How about west 60 degrees north? Isn't that the same thing? It's going in a westerly fashion, but back 60 degrees. See how it can be written both ways? Does everybody understand that? Do we understand that? We okay with that? Okay. So on these problems with sometimes airplanes or boats or things like that, we're going to go to the top of number 5. Once again, try to cover up the picture so you're not looking at it. Okay? It talks about, there is a boat. He leaves the port. Where's your port? Right there. I just said he was. That's where the port is. Port. Okay, it says that this boat is traveling at 20 nautical miles per hour, or 20 knots per hour, right? A nautical mile is not a normal mile. I don't know what the conversion is. I don't know. Should we Google that? Let's Google. Oh yeah, boats go really fast. No, they don't. I've been on a boat going to Catalina and it takes forever. I don't know why that turns off all of a sudden, but it does. But do you think you can see that? That'd be kind of interesting, wouldn't it? Anyway, here we go. So it says a sheep leaves the port. Okay, a ship leaves the port and heads due west. What does due west mean? Just straight west. He's not moving anywhere. So here's the port. He's going directly that direction. He's not going north, south, east, or west. Well, yes, he is going west. Straight on it, right? Straight on the axis, basically, right? Okay? And he's going 20 nautical miles per hour. At 2 p.m., so how long has he traveled? 2 hours, so how long has he went? 40 knots. Does everybody understand how this is 40 knots? I don't mock you. Yes, I do, actually. But anyway, at 2 p.m., he changes his direction, correct? He changes his direction north, 54 degrees west. So what I do is at that, I put a little point. Okay? Never eat shredded wheat. Okay, when I was younger, it was just shredded wheat. Not frosted shredded wheat. It was just the shredded wheat crap. Now you got frosted on it, semi-decent. It's just shredded wheat. North, 54 degrees west. So this angle right here is 54. Does everybody understand that? No. Okay. Hey, guys, let's stay on track. So, that's 54 degrees west, right? How long did he travel? It says, well, how long is the, oh, sorry. It says right here. I'll just read it. It says, find the ship's bearing. Oh, we forgot to talk about the bearing last time. And the distance from the port at 3 p.m. Okay? Does everybody understand that? Yes, no? Okay, so what we're saying is how far is he away from here? If he did, like as an eagle flies, maybe there's an island in his way. That's why he didn't go that way, let's pretend. Okay? So maybe he couldn't go that way because there's this big old island. And he had to go around it a little bit. Because obviously we all know going one distance to another distance is easier to go that straight line, correct? Okay? So but maybe there was a reason why this guy had to go this way. So, how far though is he away from the port? Well, remember from here to here, that's 1 hour as well, because it said at 2 o'clock he went here, but then at 3 o'clock he stopped, right? Basically. So this is also 20. Okay, can anybody see a predicament with what kind of triangle we have right here? We've only been studying right triangles, right? Later I can find you this by using the law of cosines. Okay, there is a way to do it. It's called the law of How did you get that? Okay. How did you get 90? From north to west, that's a 90-degree angle, right? Notice we cut back 54 degrees, so if I use a little bit more, that would be 36. Does everybody understand how he's 36? Okay? Now, if you'll also notice, I can make a big right triangle if I want. I'm going to call this guy X right now, this guy Y, and this guy Z. Everybody see that? Yes, no? On this big triangle, what's this distance? It's X plus 40, isn't it? Everybody understand that? This long distance on this big triangle, do you see that? What's this height? Still Y, and then this guy is Z. Does everybody understand that? Okay? So notice, if we're able to find this amount here, then we'll have the base of this triangle, and we can find the Y value by doing Pythagorean theorem, can't we? Find this. Does everybody see that? Then notice I'll have this length plus this length, and I can do Pythagorean theorem to find that length. Okay? Everybody see what I'm kind of going at there? Alright, so let's do it to it. Here we go. How are we going to find X? Anybody want to help me out find X, please? Go ahead, Alex. Good, because I'm standing here, so this guy would be your adjacent, right? And this would be your hypotenuse. Does everybody see X is, well, it would be, cosine of 36 is X over 20. Does everybody see that? So then you go, and I just go ahead and times the 20 over. So X equals 20 cosine of 36. Okay. Who is going to put that in their calculator for me? All of y'all. Awesome. Why am I not going to plug that into my calculator at this time? Because it's not my final thing, huh? Okay, so what I know is X is this. So now this is distance is 20 cosine of 36 plus 40. That's what that length is, isn't it? Everybody see how I found that? Maybe thinking, what? That looks like a mistake. Somebody looks like this? That doesn't look like that? No? I'll shut up. Okay. How are we going to go ahead and find Y? Oh, look at this. Oh, okay, you could do that as well, because in order you can understand this is 90, right? Plus 54, plus what is 180? You can do that as well. I didn't think about it that way. I just thought about, those, kind of in a way I did, because if that was 90, then that had to be 90, right? Does that make sense to you? Okay, I'm with you. Alright, so how can I find Y? Anybody want to help me with Y? Anybody Y? Anybody Y? We got to find out over here Y. Ooh, there we go, we got to go. Okay, we could use tangent. I'm not going to use tangent. Sine would be better, right? Because then you're using this guy in terms of that. I don't want to play with that, to be honest with you. So, but sine works just as well, right? Sine of 36 equals the Y over the 20. Now what? Multiply it over, so therefore Y is 20 sine of 36. Does everybody understand that? Yes, no, maybe so? Anybody have a question? Okay. So now we need to find Z. How are we going to find Z? Jackson, you okay? You're looking at that a little weird. Okay. Everybody good? Okay. How do we find Z? We have two sides, so Pythagorean theorem. So how do I plug this in my calculator? Because I don't want to plug in what that value is yet, because that would be estimating, right? So once again, I'm going to go to my calculator. don't remember those commercials here. I'm in degree mode. I should be in degree mode. So notice I'm going to take this 20 sine of 36. Oops, hold on. Parenthesize that sucker first. 20 sine of 36 double squared. So that's that side squared, right? Everybody see that? Plus, parentheses, was it 40 plus 20 cosine of 36, wasn't it? Double squared. Enter. 3,294. But notice, remember, that is y squared. So what do we do? Take the square root. How do we take the square root of that without estimating? Square root of answer, or do you guys remember how you could actually write it as a power? What is it as a power? Do you remember what a square root is as a power? The 1/2 power, so I'm going to put 0.5. How many of you guys remember that from last year? Not too many, that's not good. So remember, like a cube root is the 1/3 power, right? The 4th root is the 1/4 power. Okay, so instead of having to do that, I personally just raise it to its power instead. It's okay, or you could do the square root, such as the square root, and then hit the answer button. Right? That would work just as well. 57.4, roughly. So, I know that z is 57.4 miles. So notice, technically, I mean, yeah, I would have saved some distance. I would have saved 5.6 miles if I would have went straight instead of going over 40 and then up 20, right? Does that make sense? I would have saved about 5.4 miles if I went straight. But what was the last part that it asked us to do? It said find the distance and the bearing, didn't it? So that means I need to find this angle right here. Well, that's pretty easy. If I'm standing here, I have these two sides, right? So that should be the tangent of this angle is this over this, correct? So how do I find the angle? I do the arc tangent, right? So I go arc tangent, okay? So arc tangent of, notice, make sure you put parentheses around the first one, 20 sine of 36 close, divided by open, 40 plus the 20 cosine of 36, close. 11.81 or 82 degrees. Has anybody else got that? Okay. So this is 11.82. Can anybody tell me that bearing? This is bearing. West roughly 12 degrees north. Does everybody see that? He's going west, cutting back 8 degrees. How I found that? So this is the calculator. You want me to show you what I plugged in? You're in the right mode. Just put a lot of parentheses. Is that what it says in the book as well? Did we get the thing? Yes, we did. So notice it says that we're going north 78 degrees west, but isn't west 12 degrees north the same thing? Okay, everybody got that? Pretty simple. Just had to do a lot of stuff to get to the destination we wanted, right? Onward and upward, everybody, let's go. Flip it over 356. Yes! You're taking a break all the time. So when we actually work, that's why you have a hard time. Because you're huffing and puffing in your brain right now. Huffing and puffing. Your brain is out of shape. That's why you want to take a break. I believe in you. Okay. I'm just playing with you. Here we go. So we got a spring. Okay? I'm going to make up my own spring problem. So, a spring. Notice when you actually have a spring, it just dangles like this, right? Okay, and then when you actually pull the spring, it goes a lot farther, doesn't it? Then when you let go, what happens? At one point it does go here, and then it goes back to the spot that it goes the shortest. this because it's really tight, right? And then it goes all the way back to where it starts, doesn't it? What does that look like? It's a sine graph. Dun, dun, dun. You see the sine graph? Okay, let's pretend its maximum displacement was 5 centimeters past its original spot. So this could be our midline, right? But for me, let's say this is 5 inches away. Okay? I want you to tell me, okay, let's say after that, when we displace it, how far we're pulling it, it goes away 4 inches. So what's this? How far is this away from the board? 9 inches. How far is this one away from the board? Can you help me? 1. How'd you get it? Who said it? Who said it? Who said it? I heard it. Right there, Cassidy. Go. Why? Well, because notice it's like a sine graph. It has an amplitude of 4, right? It's being stretched, but then it gets shrunk back up the same kind of a distance. Does that make sense? Okay, so that's 1. And then this goes back to the 5, right? Let's say it takes it to go all the way back to its maximum displacement and its minimum displacement away from the board. It takes a total of 6 seconds. Write me an equation. I want to know the distance away from the board at any time. So what do we got? Now, this is semi-mini confusing a little bit, I'll be honest. What kind of graph is this? Sine. What's our amplitude? 4, positive or negative? Okay, let's think about this though. Can you have a negative distance? So I understand he's at 0, but then he's pulling to the farthest place away. So he's going 5 inches where he's normally at, plus 4 more. So you would actually put a positive 4 here. That's a little different just because the fact of the matter, it looks like it's negative because we're pulling him down, but at the same time his distance being negative on that place, so it's the distance away from the board. You know what I'm saying by that? So is our midline at 5 or negative 5? 5. Does everybody understand that? Okay. How long is our period? How long did it take it to get all the way back to where we wanted it to be after its maximum and minimum displacement? 6 seconds. What's our normal period? Normal period. 2 pi. Can you hear me back there, Tammy? Is this really good? You liking it? 2 pi times what's reciprocal gave me 6. Isn't that how we technically find our new period is 2 pi times something's reciprocal? Right? Times the b. Yes, we do. We times the b. To the other side, so he's 6 feet. So now he equals 2 pi. Now what? Divide here. And that is what? Pi thirds t. Right? Why is it t? Well, because it's judging it in seconds, aren't they? So however many seconds. X would work as well, and you could say that is your displacement away from the board. Okay? There's a lot of things in nature that has like this harmonic motion. It has like this. What else? Can anybody think of something else? How about the tide? Has its normal thing, right? And then when it's high tide, it comes a lot higher. When it's low tide, it goes a lot shorter. Goes back up. You see what I'm saying? Over here, go high tide, back, low tide, back. Got that? Waves in general. Do you see how it has a high peak and a low peak? It's normal if it was just resting type of a thing. That's a harmonic motion where we could write it as one of these graphs. Okay? A Ferris wheel has a motion. You we've already tested, we wanted to sit hang out. But we're no longer in a class that you have no choice to be in. You have a choice to be in this class. So this is what's coming. Okay. Where are you going? Are you leaving early or something? Where's she going? Ooh, when again? Last 2 weeks. We will chitty chat. Why would you be going then? Just because it's the best time to travel? Totally, totally. Who wants to go with tourists? I actually like tourists. Huh? Oh, terrorists? Did I say terrorists? Did you say? I heard you say tourists. I'm glad you said nose problems because I didn't think you were stuck up. My friend, I think she was stuck up in high school. She was so short, she was like basically what Jackson is. Okay. And so they always looked like this, and she's like, well, I just had to look up to people. I'm like, no, you just thought you were better. But no, I had to look tall because I was really taller. Did you ever look up a lot? See? And now you're stuck up. I know, I know! As another play on words. Oh. Okay. Okay, your homework, I already gave it to you, correct? I would like to set one up, double we can hint. Number 34. Page 360. I already gave you your homework. This is part of one of them, yes. 34. Has a lot of remembrance of a previous problem on a previous test. Maybe. That's a tower. That's a tower. Okay, I don't know how to draw. They look like they're jellyfish. Jackson. These guys are due west of each other. Huh? Whatever. Don't make fun of me because I don't. This is my best person. Sit Baker. Hey, shush. Sometimes you break it, okay? I don't mock you and your look. They are 30 kilometers away from each other. We see a blazing fire. Oh, that's bad. Fire in the forest. I just put a lot of stuff into different colors. Anyway, they see a fire. Okay? They want to know the distance they are away from that fire. This way. It says they have a lovely, what did I call these? Tower A and Tower B. It says Tower A has the bearings of east 14 degrees north. So that has east 14 degrees north. Notice you're going easterly and 14 degrees north. Does that make sense how I got that bearing? This guy is west 34 degrees north, I think. Is it 34? This is due west, and this guy is a distance. That is perpendicular, right? Hey, what's the problem, though? Am I too fast? I do. Did we not record this on the last one? So, with that being said, do I know this distance this is away from this line? I don't. We can't say it's an angle. We don't know, because these are the same, so obviously we didn't cut them in half. So this guy is X. If I call him X, Alec, what is this one? 30 minus X. Good. Does everybody understand that? Because those two added together have to equal 30, correct? How many triangles do I got? Well, I do have 3, but only 2 of them I'm going to use because why? They are right triangles, right? I got this guy. That's Making Fight song. Sorry, I have it in my head right now. I went to Bingham for 2 years. I was a mighty miner for 2 years, and then I became a lovely silver wolf. And then, this is D, and this was 30 minus X, and this is 34. I want to find that distance where it went. You guys did so well on it last time. We're going to throw it at you again. This is like your 5th time being warned about this question. Okay. So, tangent of 14 equals D over X. And what's this one? Tangent of 34 equals what? D over 30 minus X. So once again, I could solve for D, or I could do it another way. I'm going to try another way because last time maybe it didn't help you guys. So I'm going to solve for D on both of them. X tangent of 14 equals D. Does everybody understand on that one? And D equals 30 minus X times the tangent of 34. Now on your test last time, some people got here, but then they didn't put parentheses around this, so they only distributed it to the X. You see how that's a dilemma if you don't put the parentheses around it? Right? By the way, I need chip jelly. I love it. Okay, so we distribute, or we could now use substitution because see how those D's are the same? So I know X tangent of 14 equals, I'm going to distribute 30 tangent of 34 minus X tangent of 34. Is everybody okay there? I distributed the tangent of 34 into the 30 minus X. Now we want everything with an X on which side? Let's go to the left. I'm going to add him over. So I have X tangent of 14 plus X tangent of 34 equals 30 tangent of 34. What do those guys on the left-hand side have in common? Next. And I'm going to stop here and let you guys decide what to do. What do you do there? You divide what? Tangent 14 plus tangent of 34, right? Does that give us what we're looking for? It does not give us what we're looking for. That gives us X. What are we looking for? We're looking for D, aren't we? Correct?